I will be covering mechanics, and in today's tech lecture, I will try to cover vectors. So as you all know that there are two topics which are very important in your class. The first one is the vectors, and the second one is the calculus. So in every chapter, if you have a good hand of vectors and calculus, in calculus, I mean the differential calculus and the integral calculus. So you have a good hand in both the vectors and in the calculus, you will have a good numerical solving skills. So in this course, I will focus mainly on the numerical solving skills. And in today's lecture, firstly, I will talk about the vectors. Then I will talk about the universal unit vectors. Then I will talk about the Cartesian form of vectors. And then I will talk about the addition of vectors. And addition of vectors in polar form. Okay. And in this addition of vectors, I will mainly focus on the parallelogram law of addition. I will skip the triangles law of addition because both are same. And then I will talk about the subtraction of vectors. And I will lastly talk about the resolution of the vectors. So first, what is a vector quantity?
So
So,
we already did vectors in our last class.
huh?
So
Sorry?
we did vectors in our last class also.
Okay, so let's revise that again here. Is that a
Okay.
problem for you?
No, sir, no, sir.
Okay. So you will have your revision of vectors. And this vector and calculus are very important. So it is very important. Okay, so let's revise that. So firstly, there are two types of physical quantity. So one is what? One is a vector quantity, and the other one is the scalar quantity. So vector quantity have what? Magnitude plus direction, and scalar quantity have only magnitudes. Okay, so can you tell one scalar quantity? Can you tell about the one scalar quantity? Heather, you have already studied about the vectors. So which quantity is a scalar quantity? Which physical quantity is a scalar quantity? Can you give one example of a scalar quantity?
Current.
What?
Volume.
Volume, yes, volume is a scalar quantity. Yes, it's length cube. So volume is a scalar quantity. And
And
let's say temperature of the room. Okay,
speed,
temperature. Huh?
speed,
Speed, yes, speed is also a scalar quantity. So
Distance.
distance is also a scalar quantity, yes. So these are all the examples of a scalar quantity, because we only need a magnitude to represent this temperature. You only need a number. So you say that the temperature of the room is 25 degrees C. So you only need a number to represent the temperature of the room. Or for the case of speed, you only need, let's say, a body is traveling with the speed of 25 kilometer per second. So you only need a number to represent that quantity. So that's why this quantity is called the scalar quantity. And in case of a vector, you also need a direction to represent that quantity. So one example is being the velocity. So to represent a velocity, you have to say that the body is traveling with the velocity of 30 kilometer per second, let's say. And lastly, you will also have to tell the direction. So the direction being north, west, or south, etc. So to represent the velocity of a body, you need magnitude and direction also. So this is an example of a vector quantity. And one more example is force acting on two charges. It's also a vector quantity. So you see that your first chapter in 12th class is electrostatic charges and you have forces. So you need vectors to understand this chapter force. And in second chapter, you have electrostatic potential and capacitance. So you also need there to know about the vectors. So vectors and third or fourth and so on. So you need to learn about vectors first to understand more properly about the subsequent chapters in your classes. So force is also a vector quantity. And what are other examples? Can you name a few? One example.
displacement,
Yes. Displacement.
uh,
Displacement.
acceleration,
Yes, acceleration.
then
And so on. Torque and momentum, linear momentum, angular momentum, all others are, these are all the vector quantity. Okay. So how do you represent a vector? Let's say A is a vector. So this has two components, as I said earlier. One is the magnitude and the other one is the direction. Understood? So this is the magnitude and this is the direction of the vector A. Okay. So this is also called the unit vector. Why a unit vector? Because its magnitude is 1. Magnitude is 1. That's why it is called a unit vector. So the vector has two components. One is the magnitude and this one is the unit vector. And its magnitude is 1 and it only shows the direction of the vector. Okay, understood up to this point? Am I audible to anyone? Understood up to this point?
Yes, sir.
Okay. So the next topic that I will be talking about is the universal unit vectors. So let's talk about 3 dimension. In 3D, you need how many points to represent a point? How many odd coordinate you need to represent a point in 3 dimension? Huh?
3 coordinates.
Yes, 3 coordinates. So let's say you have 3 coordinates. Okay. So this is X, this is Y, and this is Z. Okay. So the universal unit vectors. They are unit vectors in all these 3 directions. So in X direction, you have a unit vector I hat, and in the Y direction, you have a unit vector J hat, and in Z direction, you have a unit vector K hat. So these are called the universal unit vectors. And the property of these vectors are what? Their magnitudes are 1. Okay. And the second property of these vectors, when I will be discussing about the dot product, you will note that these are also mutually perpendicular to each other. Okay. So I, J, and K all are mutually perpendicular to each other. So they have 2 properties. One is being that their magnitudes are 1. And the second one is that they are mutually perpendicular to each other. Okay. So this is all about the universal unit vectors. And the third topic is the Cartesian form of a vectors. So you can represent or you can break any vectors in the form of these universal unit vectors. Let's say you have a vector A. So you can break this vector into 3 components of universal vectors, unit vectors. So the vector with the component which is in the X direction is called the AX part, and the component which is in the Y direction is called the AY component, and then you have the Z component of the vector. Okay. So that is how you represent a vector in the form of these universal vectors in the Cartesian form. Cartesian form meaning that they are in the XYZ coordinates. Okay. So what will be the magnitude of this vector? The magnitude of this vector will be simply AX square plus AY square plus AZ square root over. So this is the magnitude of this vector, and what will be the direction? So as I have said earlier, what is the direction of a vector? Heather, what is the direction of this vector? What will be the direction of this vector? I can write this vector as magnitude and direction. So what will be the direction of this vector?
The direction of which vector? This A.
This A vector, this A vector. You know that the direction I is in the X direction, J is in the Y direction, K is in the K direction.
Yes.
So the direction of this vector is A hat. Okay.
Yes, sir.
And you can calculate A hat from this using this and this part.
Yes,
so the direction of A will be A vector divided by
magnitude of A.
magnitude. Yes. So this is the direction of this vector. Okay.
Yes,
So
sir.
the direction of this vector will be A hat divided by ax square plus ay square plus az square. So this is the direction of this vector. Or let's say you have two vectors. We will do this question later. So let's say you have two vectors, A, which is let's say 3i plus 4j plus 7k. Okay. And there is another vector B, which is 2i plus 3j plus 6k. Okay. So what will be the resultant of this vector, or what will be the addition of this vector? The addition of this vector will be simply plus. So we have 3i plus 4j plus 7k and 2i plus 3j plus 6k. So the total will be simply I with I, the like terms add each other. So 7j and 11k. Okay. And what will be the magnitude of this vector A plus B? So what will be the magnitude of this vector? Anyone? Heather, what will be the magnitude of this vector?
But we'll just add the respective terms and add I, J, K, set of them.
The magnitude is, the rx square plus ry square plus rz square. This is the magnitude, na?
Yes, sir.
So the magnitude will be 5 square plus 7 square plus 11 square. Okay. So 25, 49, 121. And this will be what? 9, 5, 15. And 2, 1, 3, 4, 7, 2, 9. 9, 195. Okay. So this is the magnitude of this vector. Vector R. Okay.
Okay, sir.
And the direction will be what? Direction will be?
The direction will be r
Yeah.
cap divided by root 195.
Yes, R vector divided by, this is R cap. This is root 195. So this is the direction of this vector. So in universal Cartesian representation of vector, you can simply add the vector, you can calculate the magnitude of the vector, and you can calculate the direction of the vector. But we'll see that what happens when you are given a polar form of the vector. Okay. So let's do this question first, and then we'll move on to the next topic. Okay. Shoot. So let's do this question together. Okay. This is a question of CBSE AIPMT 1999. And we'll do this together. So is everyone with me?
Yes, sir.
So what is given here? Let's dissect this question. So if a unit vector is represented by 5a, 8j plus ck, then the value of c is what? Okay. So the first thing is given in this question is what?
Unit
First,
vector.
unit vector, yes. The first information is this is a unit vector. And This is the only information. And you have also given the vector. Let's say this is the vector A, which is 0.5i plus 0.8j plus ck. Okay. So here it is asking about the value of C. Okay. So how can we calculate the value of C? What we have to find here? Yes?
Magnitude is equal to 1. So
Okay.
root over the
Yes. So we will first calculate the magnitude of this vector. So what will be the magnitude of this vector? It is 0.5 square plus 0.8 square plus c square, right? And the left hand side is what? Anyone?
1.
Yes. So the left hand side is 1 and you have 0.5 square plus 0.8 square plus c square. So let's square in both the sides. So this is 1, this is 0. This is what? 25. And this is 0.8464. And this is c square. Okay.
Yes, sir.
So c square is what? C square is 1 minus 0.25 minus 0.64. So this is 1 minus 9 and this is what? 8. So this is 1.00 minus 0.89, which means 1 and this is 1. So 0.11 c square. So what will be the value of c?
Root 0.1.
Yes. So this is root 0.11. Okay. So what was the... So this is B is the correct answer. Understood up to this point?
Yes, sir.
So the next topic that I am going to talk about is the addition of vectors. Okay, so let's say you have two vectors. One is, let's say this. This is A vector and the other one is B. So here one thing is that the Cartesian form is not given. So, and you have also one thing given is that the angle between them is theta. Okay. So you have given two vectors A and B, and what will be A plus B, which is the resultant of this vector. So there are three laws, or mainly there are two laws, which says about the addition of vectors. One is the parallelogram law, and the other one is the triangles law. Okay, so what is a parallelograms law? So you have given two vectors, vector A and vector B. So first what you do is that there are two parts of a vector. One is, this is called the tail of a vector. Tail of a vector. And this is the head of a vector. Okay. So first what you do is that, according to parallelograms law, first you do is that you keep the tail of the first vector and join and place another vector on the tail of the other vector. So this is B. Okay. So the first part is that you put both the tails together. Okay. And secondly, what you do is that at the head of the first vector, you draw a parallel distance, which is way equivalent to the B vector, the second vector. So you draw a vector which is as the same magnitude as B and same direction as B. So you shift B to here. Okay. And thirdly, what you do is that you again start from the head of this vector and you draw a parallel with the same magnitude of A and same direction of A. So you see that you form a what? Parallelogram. Okay, understood?
Yes,
And you draw the diagonal from the co-initial point. So the diagonal is the resultant of this vector. So this is the parallelograms law. You understood the parallelogram law, no? Everybody understood the parallelograms law?
Yes, sir.
Okay. So I will not write the definitions of this parallelogram law. You know that what you do is that you put the tails of the first one and then draw the parallel lines and then join the diagonal. So that is the parallelograms law. And what will be the magnitude and direction of the vectors, the resultant vector in the parallelograms law? Triangles law is the same, but in this, what you do is that this is a vector A, and you put the tail of the other vector on the head of this vector. So, and you join the third side. So this is the triangles law. Both are actually roughly the same. Okay. So both are used to calculate the resultant of a vector. So let me again draw the parallelogram here. So this is A, and this is B. And the angle between A and B is theta. Okay. So this angle is theta. And what will be this angle? From the linear property of a line, linear sum property of the line, what will be this angle? Anyone?
sorry, sir.
What will be the angle, this angle? So you know that a line makes a total of an angle of pi or 180.
180 minus theta.
Yes, so this will be 180 minus theta or pi minus theta. Okay. So before I calculate the magnitude and direction of this vector, let me revise you two very important properties of a triangle. Okay. So revision or recap of a triangle. One property of a triangle is called the law of cosines. Okay. So in law of cosines, you have given, let's say this is A, this is alpha, this is, let's say B, and opposite to this is beta, and this is C, and you have gamma. Okay. So according to law of cosines, the third side, the square of the third side is equals to the square of the first two sides minus the product of the two sides into the cos of the angle opposite to this third side. Okay. So this is the law of cosine for a triangle. Understood? I am telling you this because these are very important. Okay.
Yes, sir.
And the second property of a triangle is called the law of sines. And you have already heard this about in Lame's theorem. So what is law of sines? Is that again the same triangle. So you have beta, gamma, alpha opposite to A, B, C. So the law of sine says that the value of C by sine gamma will be equals to B by sine beta and will be A by sine alpha. Okay. So these are the law of sines and cosines of a triangle. Understood up to this point?
Yes, sir.
So where were we? We were at the magnitude of a vector in a parallelogram's law. So this was your diagram. Oh. So this was B, this was A, this is again B, and this is again A. And this was the resultant. And the angle between A and B was theta. And the angle between the A and the resultant is alpha. Okay. So what we will do is that we will extend this line and we'll draw a perpendicular. And what is this angle? I have drawn. This angle is theta. And this is, okay. So I should talk about the resolution. Let's just say that if you have a vector B, okay, and this is theta, so this will be B cos theta, and this will be B sin theta. Okay, you have already learned this in your 10th class. Okay.
Okay, sir.
So this is what? This is
B cos theta.
yes, this is B cos theta, and this is B sin theta. Okay, so you have R, this is A plus B cos theta, this is B sin theta. So from Pythagoras theorem, we can calculate R. Na? So what will be R?
A plus B cos theta square plus B sin theta square.
Yes. So this is, and so this is what? This is A square plus B square cos square theta plus 2AB cos theta plus B square sin square theta. So B square is common. So we can, oops, So this is a square plus 2ab cos theta and plus b square common sine square theta plus, and this angle is what? This angle is what?
Theta
This is alpha.
alpha.
Theta is angle between two vectors. Okay. And alpha is the angle between vector A and the resultant. So this was the vector A and the resultant. So this angle is alpha. So where were you? So this is cos square theta, and you already know that this is what? This is 1. Okay. So the resultant will be a square plus b square plus 2ab cos theta. And this is r square. So this is root over. So this is the resultant of the two vectors. Understood up to this point?
Yes, sir.
And this is called the cosine law. And you will say that how this is the cosine's law? In cosine's law, what was the cosine's law? Let's make a triangle and recall. So this was gamma, this was alpha, this was beta, this is A, this is B, this is C. And what was the cosine's law? Can anybody recall? C square is equals to A square plus B square minus 2AB cos gamma. Okay. So this was the cosine's law. And does it match with this resultant of the vector? Anyone?
Yes, sir. It does match with it.
It matches. There is a minus sign and there is a.
If we square it, then.
So if you square this, this will be what? R square is equals to A square plus B square plus 2AB cos theta. Okay.
Yeah, there's a plus sign difference.
Yes, there is a plus sign, but there is a minus sign. But why am I calling this a cosine's law? So let's draw the triangle first. Okay. So this was the triangle. In case this was R, and this is alpha, this is beta, and this was theta, not this part. Okay. This was theta, na?
Yes, sir.
So this was pi minus theta. Understood? So what will be the cosine law here? So cosine law will be R square will be, let's say this is A, this is B. So A square plus B square, what? Minus 2AB cos what?
Pi minus theta.
Yes. Pi minus theta. So this is A square plus B square. And you know that in second quadrant, the cos is negative. So you will have cos theta. Understood? So we used cosine's law and you got the resultant. So this is another way you can find the resultant of this vector by using the property of a triangle. Understood up to this point?
Yes, sir.
Okay.
Yes, sir.
So this was the resultant. So we calculated the resultant of a vector, let's say magnitude. And this was r hat is a square plus b square. And what about the direction? Because if you have a vector, you need two things to describe a vector. One, we calculated the magnitude, and the other one is needed is the direction. So again, recall the vector. So this is alpha. Let's omit that. This is not needed. Just draw this. So this is alpha, and this is b sine theta, and this is a, and this is b cos theta. Okay, so what will be tan alpha? Can anybody tell me what will be tan alpha? Tan alpha will be perpendicular upon base. So what will be? What is the perpendicular for this angle alpha? It is b sine theta. Okay, and the base is a plus b cos theta. So the direction is alpha, which will be tan inverse b sine theta upon a plus b cos theta. So this is the direction of the vector. Understood up to this point?
Yes, sir.
So we calculated the magnitude and direction of the resultant of the vector by parallelogram's law. And now I will talk about the subtraction of vectors. Okay. So in subtraction of vector, you let me talk about one more thing, that let me talk about one more thing. Let's say special cases. Special cases. One is that both the vectors A and B, they are parallel. Here it is appearing collinear, linear, but let's say I draw like this. Okay. So both the vectors are parallel. So when I put the tail of this vector here, this will be coming like this. Okay. So this will be, let's say this is A and this is B. So these are both parallel vectors. So in this case, what is the angle here? Anyone? What is the angle here? Heather, Iram, what is the? Huh?
0 degree.
Yes, 0 degree. So theta is 0 degree. So recall that the resultant was what? Resultant was?
Square plus b square plus 2ab cos theta.
Yes. So theta is 0
1.
degree. So cos 0 is 1. So we will have a square plus b square plus 2a. Okay. So this is what? This is a plus b whole square. Okay. So this is a plus b. There will be plus minus sign, but we'll ignore the negative part. So this is a plus b. So in case of parallel vectors, your resultant is simply the addition of the magnitude of the two vectors. Understood? And you already know that the angle is again 0 degree. So direction will be the same. And the resultant direction is same. Now, if you have anti-parallel, let's say the second case. You have A, which is going like this, and you have B, which is going like this. Okay, so what will be the angle here? Iram, Heather?
180 degree.
Yes, 180 degree. Okay. So the resultant will be what? And what will be the value? What is cos 180 degree? Hmm?
1.
This is -1 because this lies in the second quadrant. So
Yes.
your 0 is 1, so this is -1. So this is a square plus b square minus 2ab. So this will be what? A minus b whole square. And this will be a minus b. Plus minus, which depends upon which magnitude is larger. So if your b is larger, then this will be b minus a. If your a is larger, then this will be a minus b. And the direction will depend upon the larger magnitude. So whichever has the largest magnitude, that direction will be in that direction. Okay. So these were the special cases. And let's recall one more thing, that if you have a vector and if I write the opposite vector which has same magnitude but the direction is directly opposite, so that will be what? Minus a vector. So this is a vector, and what will be minus a vector? This will be like this. Okay. So this has the same magnitude but opposite in direction. So the minus sign signifies the opposite direction. Understood up to this point? Hmm?
Yes, sir.
Yes.
So let's talk about the subtraction of the vectors. Okay. So in subtraction of the vectors, you again use the same law. We use the parallelograms law. And but what we do is here that let's say you have A and you have B. Okay. And you want to calculate A minus B. So what you will do is that you will take the opposite or the anti-parallel of this B, and you will extend the anti-parallel of B like this, So this is minus b. And now you will use the parallelograms law. So you draw the parallel. And this is A, and this is minus B, and this will be your A minus B. Understood? Understood up to here?
Yes, sir.
Okay. So I will not derive this, but I will just draw the equivalent triangle. And let's say, so this is, and let's say this is one here, and this. So this is, oh, so this is A, and this is what? B cos theta. Okay, so this total was A, and this was B cos theta. So this distance will be A minus B cos theta. Okay, so, oh, sorry. So when you solve again, then the resultant will come out to be A square plus B square and what was that? Minus 2AB cos theta. Understood?
The formula for magnitude will be, formula for direction will be the same.
No. The direction for the, you see that the, sorry. So the base and the base is what? This is B sine theta. And this is what? A minus B cos theta. Hai na? For this subtraction, this is the base na, and this is the alpha. Okay, for the addition one, sorry. For the addition one, we had what? For the addition one, we had this A plus B cos theta, and this was the B sine theta. Hai na? So for addition, we had this triangle. Understood? Heather, Iram.
Yes, sir.
So for subtraction, the equivalent triangle is this. Understood? The equivalent triangle is, so when you draw the perpendicular from here, so this is the equivalent triangle. Understood? This is A, and this is theta, so this is B cos theta. So this is the equivalent length. And this is the angle alpha, and this is B sine theta. So the base is what? This is the base, na? So should I prove this to you? Let me prove this one, okay? So this will be more clear. So the equivalent triangle is this, okay? Understood up to this point, na? You understand that this is the equivalent triangle for the subtraction of the vectors?
Yes.
So the magnitude will be what? Using Pythagoras theorem. So this is what? A minus B cos theta square plus B square sine square theta. So this will be A square plus B square cos square theta and minus of 2AB cos theta plus B square sine square theta. So this part gives, so, and root. So this part gives A square plus B square minus 2AB cos theta. Understood? So that is how you calculate the magnitude of a subtraction of vectors. And for the angle, you have what? You have triangle alpha. This is the resultant. And this is A minus B cos theta. Okay. And this is B sine theta. So the angle will be b sine theta upon a minus b cos theta. Understood? Heather, Iram.
Yes, sir.
So this is the magnitude and direction of the subtraction of the vectors. Okay. And lastly, in today's lecture, we will talk about the resolution of vectors. Okay. So as I have discussed earlier, that any vector can be in a plane. In a plane, what I mean is what? How many directions? So this board is a plane. So how many coordinate system do you need to represent this board? The points on the board.
Sorry, sir.
Sorry?
What did you say? Can you just repeat it?
So this board that I'm writing on is a two-dimensional plane. Okay. Understood?
Yeah.
And if I point this, let's say this is a point P. So how many coordinates do I need to use to represent this point in this plane?
One.
You need 2 points. Now you have to tell the x coordinate and y coordinate. You divide and you make a mesh, and then you tell that this is at the 3, 5, at 3, 5 point at x equals to 3 and y equals to 4. So in a plane, for a two-dimensional object, you need 2 points to represent a point, to 2 coordinates to represent a point. Na?
Yes, sir.
Yes. So so a vector in a plane, let's say this is a vector A in a plane, can be divided into 2 parts. One is the horizontal part, and this is the vertical part. Understood? So this makes an angle with theta with the horizontal part. So this is A cos theta, and you know that this is in the x direction. So what will be, and this is in the y direction. So what will be the unit vector here? What will be the unit vector here?
J cap.
Iram, it's I, na?
So it's along which side, which axis?
This is the x-axis.
X-axis, then I cap is.
Yes, and this is y-axis. So this is A sine theta j hat. So you can represent this vector A as A cos theta I hat plus A sine theta j hat. And this is AX, like the Cartesian form. So you see that this is Cartesian form and this is what? The polar form. So here your AX is what? A cos theta, and your AY is A sine theta. So this is all about the resolution of a vector. Understood?
Yes, sir.
So let me give you a simple question. I will solve this later. Let me first solve a simple question. So let's say you have a force F, which is of magnitude 20 Newton, and this makes an angle of 30 degree with the horizontal. Okay. So what will be the horizontal component or the x component of this vector f? Magnitude is 20 Newton, and what will be fx? Heather, what will be fx?
X is the direction, right?
Hmm?
X will be the direction of this.
Yes,
vector.
yes. Fx is the x component of this force, the horizontal component of the force.
30 degrees.
Now, I'm talking about the component. This is force, the component will be the force, na? I'm talking about the force, and the component of a force will also be a force, na? I'm not talking about the direction. So let's say in the Cartesian form. Yeah. So you see that, let's say this is a vector 0.5a, 0.8 ck. So the ax component of this vector was what? 0.5.
Right.
Yes. So similarly, you have a vector f. Let me draw a proper diagram. So this is a vector f, okay, and it has magnitude 20 Newton, and this makes a 30-degree angle. Okay. So I am asking what is fx, meaning what is the value of this f in the x direction, and what is the value of f in the y direction, that is fy. So let's recall what is the x component in the polar form. This is the x component now.
F cos 30.
Yes. So fx will be f cos 30 degree. This is the horizontal component or the x component of the force. Hannah?
Yes, sir.
And what will be the vertical component?
F y a sin f y sin
F sine 30. F sine 30. Okay.
and 16.
So cos 30 is root 3 by 2. So this will be 20 into root 3 by 2. So 10 root 3. Understood. And this will be sine 30 is what? This f is to,
y component will be sin 30 or sin 60.
huh?
Fy component will be sin 30 or sin 60.
See here. So let's again draw a diagram. Hmm. So this is 20 Newton. Let's say F. This is 30 degree. So let's say this is theta. Okay. So the horizontal component was what? F cos theta. And the vertical was F sine theta, not 90 minus theta. This was the same as this one.
Yes, sir.
So if this is 30, then this will also be 30.
Okay.
So this will be f sine 30. Understood?
Yes.
So so this was sine 30 is 1 by 2, so 10. So this is 10. Okay. So if I write this f in the Cartesian form, what will it look like? So you have fx I plus fy j. So fx we calculated 10 root 3 I hat plus fy we calculated 10. So this is 10 j hat. So this f is 10 root 3 I plus 10 j hat. Understood? So if I was given an angle, let's say, and the component magnitude. Understood? So then I can always calculate the Cartesian form of the vector. Understood up to this point? Do you have any questions up to this point? Any questions? Iram, who has left the class? Okay, so Heather has left the class. Iram, do you have any questions?
No, sir.
Okay. So there must be a connection issue, or he may have not liked the class. Those two possibilities. So where was I? So let's solve this question. This is a very complicated looking diagram, but we will dissect this and we'll try to solve this question. Okay. Oh, so Heather. Welcome again, Heather. Connection problem. Hello, Heather. Can you hear me? Hello.
Hello?
Can you hear me?
Yes, sir. Yes.
Connection problem.
Yes, sir. There was a slight power cut.
Okay. No issue. No issues. No issue. So did you understand up to this point, or do you have any doubt?
No, sir. I understood it.
Okay. So now we will try to solve this question. This is very complicated looking question, but we'll dissect this in many parts and then we will try to solve this question. Okay. So you already know that what is the resultant of two vectors. This is A plus B. Okay. And here in this question, this is asking the resultant of these forces OP, OQ, OR, OS, and OT. And what does it mean here by bold letters? Can anybody tell?
Magnitude of those.
No, they are representing in bold letters because they are vectors. Okay.
Right.
So that is why they are writing it in the bold letters. They are not writing the arrows. So they are only making it bold to represent a vector. So, so they want us to calculate the resultant of these forces. So Heather, please tell me, let's say the resultant is F. So what will be the resultant of OP, OQ, OR, OS, and OT?
So we will apply parallelogram to two forces at once.
The resultant, let's say there are three vectors. So the resultant will be A plus B plus C. We can try to calculate multiple parallelograms law, but let's just say we calculate the Cartesian forms of each vector. You already know that we can calculate the Cartesian forms here. Understood? So if you are given the angle and the magnitude, what you can calculate? Heather,
Yes, sir.
you can calculate the Cartesian form of the this vector, na?
Yes, sir.
And if you have the Cartesian form of the vectors, you can calculate multiple resultant of the vectors.
Yes.
So let's say you have let's say A, this is 4i plus 3j plus 7k, and you have B, which is 3i plus 2j plus 3k, and you have C, which is something I, something j. So you can always calculate resultant as A plus B plus C because it is easy in the Cartesian form. Understood?
Yes, sir.
So our goal will be that we calculate separately the Cartesian form of these. This is not these vectors. Okay. And then we'll do what? We will simply add those vectors. So now can you tell me what will be the resultant of these four vectors? Simple. It will be OP plus OQ plus OR.
RO plus YO plus SO plus.
OS. How many terms did I write? These are 1, 2, 3, 4. Yes. So OT.
OT.
Understood?
Yes, sir.
So what is our goal? We'll be calculated the Cartesian form of each and every vectors. So this will be enough to calculate the total resultant. Understood?
Yes, sir.
And then and if we have the Cartesian form, then we'll calculate the magnitude and the direction. Understood?
Yes, sir.
So let's calculate, or let us first draw this horrific diagram. So firstly, we'll calculate OP. So let's just focus on OP. So you see that this is OP and the magnitude is 20 Newton. So let's OP magnitude is 20 Newton. Okay. And theta is what? So we always calculate the theta with the horizontal. We always associate the angle with the horizontal part. Understood? So what will be the angle here? The angle of OP with the horizontal? Here. This is with the vertical. Na? Your Y is vertical, X is horizontal. So this is making 30° with the vertical. So for the horizontal, so this is the horizontal. So this will be what?
90
60?
minus 30.
Yes, 60. So this is 60. So your theta is 60. So all thing is done. Now you can calculate vector OP. And what will be the vector OP? First, we will calculate the horizontal component. This will be what? 20 cos 60. And this is what? 20 root, no. Cos 60 is what? Heather, cos 60
1
is
by
what?
2.
Yes, 1 by 2. So this is 10. So this is 10 and your OP Y is what? 20 sine 60. Okay. So this is 20 root 3 by 2. So this is 10. So this is 10 root 3. Understood?
Yes, sir.
So what will be OP vector? Your X and Y are here. So what will be OP vector? Iram, what will be OP vector? So this will be,
10
yes,
iota
10 iota
plus 10 3
root 3 j cap. So this is the OP vector. Okay, Heather.
Yes, sir.
And now I will, you guys will try to calculate OQ. So who is going to explain me OQ?
So first we'll calculate the x component of OQ. in
Let's
which
move this figure here.
in which we'll first find out OQX by
Yes.
which
So
will
let's,
be 10 cos 30.
where is OQ? So this is OQ. Yes. So OQ is 10 Newton and theta is 30. Okay. So OQX is what? 10 cos 30. Yes.
Yes, sir.
And this is 10 root 3 by 2. Okay. And you said OQY was what? OQY was
60°. 10 Newton.
10
10 sine 60.
not sine 60, sine 30. No? Your theta can't change.
Yes, sir. Sine 30. Sine
So
30.
this is theta, this is also theta. So this is 1 by 2. So this is 5. So this is 5. Okay. So we are nearly running out of time. So what I will do is that I will calculate each component and you try to find the answer. You take the screenshot of this question and you guys take the screenshot of this question. So when we will meet in the next class, you guys tell me the answers. Okay.
Okay, sir.
Is this fine with you, or you want me to calculate the whole answer?
It's okay.
We'll do it.
We'll
Okay.
do it.
Okay. Okay. Thank you. Thank you. So what was the other part? OR. So OR is what? Where is OR? Oh, this is. So this is OR. And the important point is that the OR is associated with what? So let's be more clear. So OR is 20. OR is 20 Newton and theta is 45. Okay. So OR X is what? 20 cos 45, which is 20 by root 2. Okay. So this is root 2 by root 2. This is 2. This is 10. So this is 10 root 2. And what is ORY? Iram? Yes, 20.
20.
What is the Y component? Y is associated with sine theta. Na? So this is 20 sine. Angle is what? 45.
45.
So sine 45. So this will be 21 by root 2. Again 10 root 2. Understood? But the trick is that the vector OR will be what? Vector OR is what? So this is 10 root 2. This is in the x direction, I. Okay. So this is 10 root 2. Who is joining the class now? Hello, Faiza. Hi. So, hello, can you hear me, Faiza? Hello? Hello, Faiza, can you hear me? So she's unable to hear me. So where was I? So yes, so this is 10 root 2 what?
I cap.
I cap. But for the jth
Minus
path.
J.
Yes. So this is in the minus j direction. So you have minus of 10 root 2 j. So this is OR. Okay. So similarly, you calculate what is need to be calculated. So OS NOT. So you guys calculate OS NOT and tell me the answer in the next class. Okay.
Okay, sir.
So do you guys have any doubt? And I will do some fast recap